This video is compiled in the course of a lecture called Research Methods for International Market Analysis. It will be the first of a series of videos provided. This first video provides an introduction to SPSS. In particular, it will start with the absolute basics, so it is addressing true beginners in SPSS. It will cover the following contents. It will speak about the basics about working with SPSS, such as saving and opening a file. It will look at the basics when working with variables and data in SPSS, such as computing new variables, filtering a dataset, and so forth. And it will moreover look at the calculation of descriptive statistics, mean, median values, variances, frequencies, and so forth. And it will look at the calculation of some inferential statistics. In particular, it will look at the T-test for a mean value, or for the difference between two mean values. The knowledge that is provided in the video basically covers all that you need for solving an exercise that is designed for the lecture. You will see the exercise slides in the course of the lecture, and they will also be uploaded in Blackboard. Going through the exercise after watching the video, you might feel that you will need some further input. For that purpose, I will recommend the book A Concise Guide to Market Research, written by Marco Sarstedt and Eric Moe. They provide an introduction to SPSS, plus provide background information on the different statistics. Have fun watching the video and playing around with the dataset in SPSS.
Okay, let's start with the basics. I assume that you have downloaded the file International Markets from Blackboard to your computer. I have done so and have saved it on a desktop. As soon as you are in your Explorer view and in the respective folder that you have saved the file in, you will see that file here with the .sav ending, letting the computer know that this is your SPSS data document. What a surprise! You can open that file by double-clicking on it. And we will do so together. When you are opening SPSS for the first time, this might take a few seconds until the file is open. It is happening here on my second monitor, so I will just pull it up here so you can see the file. After double-clicking on the file, you should view the following SPSS menu, as you can see on my computer or on my screen right now. Let us quickly see what SPSS is offering us. First of all, there you can see the menu bar in SPSS, which enables you later to perform all the different analyses that we are interested in. Before doing so, we want to jump a little bit deeper into the basics in SPSS. And one of these basics is the two different views that are offered. One is called data view and one is called variable view. Let us start with the data view. This is simply done by clicking on data view. As soon as you clicked on data view, you will see a screen such as this, and you will see that this pretty much looks the same as any kind of Excel file that you might have compiled before. You can see here that I've tried to gather some information on different international markets. So we see here a couple of different countries for which I selected a couple of different indicators. So, for example, I have collected the foreign direct investment inflows, I have collected the gross domestic product, the gross domestic product per capita, and so forth. And you can see that these numbers are the respective information that I have collected for Albania in 2015. I would say this pretty much is the same as you would have done in your Excel file. The thing that makes SPSS a little bit different from Excel is the variable view. And we will click on variable view to understand what is behind. What I would like to show you in the variable view are different columns. First one is called name, and you can see in this name column simply the names of the variables that we have seen before. So for example, economy, foreign direct investment inflow, gross domestic product per capita. So basically the headings of the data view. SPSS is giving you the opportunity here in the variable view to provide further information about these variables. And these further information are usually given in the column which is called label. I will just increase it in size so that you can see it. So basically what you can see in the label column are information or further information about the variables. An example, FDI inflow, is a foreign direct investment inflow in millions of US dollars retrieved from World Bank. So basically you can type in whatever you want in this label field. If you feel that FDI might be an abbreviation which is not so common, you might also say this is foreign direct investment inflow. Yeah? So you're completely free to write into the label whatever you would like to see there. Another thing that differentiates SPSS from Excel is something that is called values. And this is this column over here. And I will give you an example for this. There is a variable which is called top 20 emerging markets. And we can see from the label that this is the top 20 emerging markets as defined by Bloomberg in 2013. If you click into the data view to see what kind of values are in this variable, we can see that there are a couple of zeros, sometimes a 1, zeros and 1 again. So basically this variable comprises zeros and ones. I mean, it would not be very hard to guess here what a 1 and a 0 would mean, but the variable view allows you to directly specify what is behind. So what is behind here? And we'll click onto that field, and you will see that there is a small icon appearing with 3 dots. And if you click on that, you can see that a 1 means or represents that this country or this data set is among the top 20. If I click on this, you could type in whatever you want. You could also say it's among the top 20 emerging markets according to Bloomberg, and change that. I mean, that's a long text. That's a matter of preference if you want a long text or a short text. I prefer short ones, so I would cancel this and will not make that change. But you are basically able to specify the value labels. We could also say that a 0, and I will click on that again. 0 means not among top 20. And then you click on Add and click on OK, and then you have specified these values. So far, so good. What is the advantage of it? Let's jump back to the data view. We still see that we have our zeros and ones here, but we can switch on a different view in SPSS. And for that purpose, we can click on View, and we can check this box, Value Labels. And as soon as you do so, you can see that SPSS is showing here the value labels. So you immediately see that for this country, we know it is among the top 20 emerging markets. And this can be helpful if you are using different scales, for example, typical Likert scales from 1 to 5, where you are unsure whether 1 is the best category or 5 is the best category. So this will help you very much in understanding your data set.
Okay, let us jump back to the variable view to see what other options we have. We have spoken about the name and the label of a variable. We have also spoken about the values. Another thing that is of importance is the measure. And you can see here that different measures are specified for our different variables. Basically, the options that we have, we can see them by clicking in one of the fields, are scale, ordinal, and nominal. Nominal simply is a measurement where you have different categories. So for example, Argentina, Albania, Denmark, and so forth, different countries that are categories differentiating different cases. It could also be for a person, blue eyes, green eyes, brown eyes, whatever. There's another option which is called ordinal. Usually ordinal data enables you to make a ranking of different objects. So for example, if you have a scale measuring whether one person is more intelligent than another person. You could have a scale where different measures or values that you have attributed to the variable also represent differences. So that would mean if we talk about the intelligence of different people, we cannot only say that person A is more intelligent than person B, but person A is twice as intelligent as person B. So we could have a variable that measures, for example, the intelligence quotient. There's a big discussion going around in statistics whether we can say that Likert scales, for example, from 1 to 5, having a measurement of I strongly agree to I strongly disagree, are scales or rather ordinal data. I don't want to jump into this statistical discussion here, but my recommendation for using SPSS is that you specify, if possible, all variables as a scale. So all variables where you have numerical data specify them as a scale. This will make your life much easier because it will enable all different analysis procedures later. So one of the first steps that you need to do is check whether the measurement levels specified correspond to your dataset. And we can see that for almost all variables we have a scale, and for some we have a nominal. We have a nominal measure for our economies, which is absolutely right because we have different economies, different names, a string here. So nominal makes sense. We also have nominal for a variable which is called schooling years. Compulsory education, duration in years provided by the World Bank. So this is the number of years that a person went to school in a certain country. This surely is not nominal. We can argue what kind of scale it is, but we will specify it as a scale as it is a numerical value here. Same is for our top 20 emerging markets. It is among the top 20 or it's not among the top 20. So SPSS is not really wrong by saying that this is a nominal measure. Nonetheless, if we want to do any kind of analysis with these 0 and 1 measures later, it might make sense to specify it as a scale, and I will do so right here. So we have name, label, values, and measure. What else is missing? One more thing, which might be of relevance, that is the scale here or the column here, which is called missing. And we can see that we have here listed for all the variables none. What does it mean? Let us have a look into the data view. We can see in my data file that I was unable to find certain indicators for certain countries. So for example, for the British Virgin Islands, I was unable to find information about mergers and acquisitions in US dollars. And that is why SPSS here has a blank. And it does not only have a blank, it has a blank where a small dot is in. And this blank with a dot in specifies that this is a system missing value. And SPSS will not use this field for any kind of calculations. So this is not treated as 0 or as a value or whatever. SPSS knows that this is a system missing value. For some dataset, statisticians or researchers have specified missing values. So sometimes it is the case that researchers say that a -999 represents a missing value, for example. In this case, we would need to tell SPSS that a -999 is a missing value. And you would be able to do this in this column over here. So for example, if a researcher was unable to find the high-tech exports for certain countries and has typed into his dataset a -999 for all the cases where he or she was unable to find a value, we would need to tell SPSS, by clicking again on this icon here, that a -999 is a missing value. If you click on OK, you could see that -999 would represent a missing. In our case, I didn't do so. So I just left the field blank. And that is why we won't need the -999 here. So what will I do? I will just say no missing values and switch back to none.
Let us now start with some first calculations. With SPSS, you can do as many calculations as you can do with Excel and even more. But with the basics, I will show you one example of a calculation, and you can follow the same menu path for any other kind of a calculation that you want to perform. Let us take an example. We have the GDP here given in current US dollars. And if you look at the data view, we can see that these are pretty high numbers. Moreover, if we look at FDI inflow, and jump back to the variable view, we can see that these are given in millions of US dollars. So we might be interested in having the GDP also in millions of US dollars. In Excel, we would intuitively know what to do. We would just calculate and divide the GDP, current US dollars, by a million to have a number that is representing the GDP in current US dollars in millions. And we can also do by using SPSS. For doing so, we will first jump into this menu, and there's a button which is called Transform. And if you click on Transform, you can see that there's the option to compute a variable, and we will click on that. As soon as you have clicked on that, you can specify a target variable, and so that would be the new variable that you want to compute. In my example, I would like to compute the GDP in millions of US dollars. So I will say I would like to compute GDP
how can we call that? Millions or in millions. You are free to provide any kind of name that you are interested in. And then you can specify here a numeric expression, so basically the formula that you want to use to calculate the new variable. And you can see that you have a lot of functions over here that you can use. So for example, you have any kind of arithmetic functions, computation of a logarithm, cosinus, whatsoever. But you can also use very basic calculations using this field here in the middle. So we are interested in using the GDP and dividing it by 1,000,000 to come to our final number. And you can see here that SPSS is providing all the variables which are in the data set. And here again, you can tell SPSS whether you want to see by clicking on the right mouse. You can ask SPSS to display the variable labels or the variable names. And this is just a matter of preferences. As I'm pretty familiar with the dataset, I would prefer the variable names because these are shorter. But you can also use the label, it doesn't matter. So I can see that I have the variable GDP here, and I will select it and bring that into this field. What I want to do is I want to divide the GDP by 1,000,000. So I will just use my keyboard to put in the divide, or you could also click on that button here and divide it, doesn't matter. And I will divide it by 1,000,000. 1, 2, 3, 1, 2, 3. Yeah, and you can specify any kind of function. You can multiply variables, you can deduct something. Yeah, you can do whatever you would like to do. And you click on OK. And then you can see in the variable view that SPSS has created a new variable, GDP in millions. And we can also say this is GDP in, oops, sorry. That was me jumping into the wrong field. Might happen to you too. GDP in millions, in current millions of US dollars from World Bank own calculation. Put that there. Good. This is a variable view, and now we can check whether in the data view it has also created our new variable. So we will jump into the data view, and usually it puts it to the end of the data file. And here you can see it has created the GDP in millions of US dollars. There are some very high numbers. Let us see whether that can make sense. This should be a country which has a very high, and that is Brazil, which makes absolutely sense here. Let us see if we have a country where we can have an immediate check. Where is, for example, German context? That will enable me to have a quick overview. Yes, and I can see that this number also makes sense. If you jump back to the variable view, you can also say it would be nicer for me to have the GDP in millions directly after the GDP. You can just select that line and move it to any kind of position in the data file to make any kind of comparison. I would like to show you another function in SPSS, and this is a function of recoding variables. Let us take a quick example. We are interested in creating our own classification of markets. So for example, we would like to create a classification scheme building on the GDP per capita. And we would be interested in having a classification of countries into low income, middle income, and high income countries. For that purpose, we can use GDP per capita. Let us have a quick look at the values that we have in our data file. We have the variable given over here, and we can see that we have different countries with different levels. So for example, we have a GDP per capita of around 4,000 US dollars for Albania. We would now need to specify thresholds, and I will just choose some thresholds that I use as an example. I will specify countries as low-income countries as soon as they have a GDP per capita which falls below 1,000 US dollars. I will specify countries as high-income countries as soon as they have a GDP per capita above 12,000 US dollars. And you can use your own thresholds when you are asked to later. Let us see how we can do it. We will click on the menu item Transform again, And you can see that we have the option to recode a variable into a different variable. And this is the menu which opens up. Here again, we have the variables that we would like to refer to. In my example, I already did some classification, so it's given in here, but I can reset the menu to have that free. And that is the view that you should see. Let us take the example of GDP, and I will again jump to the variable names. We have GDP per capita, and we will select this variable again using the small arrow. We have GDP per capita here, and we would like to create a classification, and I will call the classification variable as simply income classification. And I will give it a label and say these are economies with low, medium, and high income as GDP per capita. And now I need to specify old and new values, and we will click for that purpose on this menu here. A new menu opens up where we can specify the old values and the new values that we are interested in assigning. So my example was that I wanted to classify countries as low income as soon as they have below 1,000 US dollars per capita income. That would mean I would be interested in having a certain range of value. That could be 0 in this example, as we have no negative values, up to 1,000. And these are my countries which fall into the smallest category, which I will assign a value of 1, low income. I would classify countries as high income as soon as they have a value of 12,000 US dollar per capita or even more. So I will say 12,000. And then I do not really know what is the highest value in my data set. I could have calculated that before, but now that I'm already in the menu, I'm kind of trapped. So I can use another option here and say I will use a certain value through the highest. So I will say 12,000 is my threshold. Through the highest value in the data set will receive a value 3. These are my high income countries. And now we would like to specify a range in between, which are the middle income countries. And that would be all the countries that are in between 1,000 and 12,000 that receive a value 2. Problem in my classification here, I don't know whether you have identified that I might run into trouble for those countries that match exactly the thresholds. So maybe my procedure was not 100% proper, and you can do better by looking at 1,001 or 12,001 as the thresholds in the different categories to make sure that you have 100% classification. I will leave it here in my example as it is. So I'm optimistic that there's no value exactly matching it. I will also tell SPSS that system missing values should remain system missing values, also for the new variable. I click on Continue. And then you can see before clicking on OK, you need to click on something else. And that's a bit of an annoying function in SPSS because you need to click on that button Change before you can do so. I will click on OK. And then let's see what has happened. Let us first jump into the variable view. We can see that SPSS has created a new variable which is called income classification with my label that I have specified. And I can also now use the idea of defining values and tell SPSS that a 1 was assigned to low income, a 2 was assigned to middle income, and a 3 was assigned to high income. Okay, let's have a look into the data view and see what happened here. We can see here that SPSS has created the new variable, middle income, high income. Let's see if we also have a low income, and we can see here a low income country. Let us quickly check if SPSS has done everything right. For low income, it should be a country with a GDP per capita which falls below 1,000. Correct. Middle income should be a country which is in the range 1,000 to 12,000. Correct. High income should be a country which is above 12,000. So this looks rather good from my first point of view. So we have now created a new classification variable which classifies countries into different categories, low, middle, and high income. And this option enables you to create any kind of classification variable that you might be interested in for your dataset. Let us now start with the first descriptive statistics. Now we have finalized all the basics, creating variables, classifying variables, and so forth. And now we would be interested in finally calculating some descriptives. One of the very basic descriptors would be a mean value, a median value, a standard deviation, and so forth. You can do that by using the menu which is called Analyze. And I will jump into the menu Analyze right now. You can see that you here have the idea of descriptive statistics, and you can see that you have frequencies and descriptives. Let us start with frequencies as an example. When you open up the menu for frequencies, you are first asked to identify or select the variables that you are interested in calculating descriptive statistics for. And I will use the GDP per capita and maybe our new variable classification of countries as low, medium, and high income. Basically, you can select as many variables as you like in this menu. I will just choose the two to keep the overview. You can see here on the right-hand side that you have further options. First option is called Statistics. If you click on Statistics, a new menu opens up. And there you can specify what kind of statistics you are interested in. So you might be interested in calculating the mean value, the median value, a standard deviation, and a variance. Just as an example, you can choose further if you want to. Click on Continue. You might furthermore be interested in having some charts. Clicking on Chart, a new menu opens up. Unfortunately, on my computer, always on the second monitor. You can choose a bar chart, a pie chart, or a histogram. We know that a histogram simply is a visualization of a frequency table. So in my example, I will choose histogram, and I will also ask SPSS to show the normal curve on that histogram. And click on Continue. You can see that you have further option over here, but for now, statistics and charts are fine for our example. I will click on OK, and then let's see what happens. As soon as clicking on OK, you will see that SPSS is opening another window. And this, unfortunately, again happened on my second monitor. So I will pull it up here. So what is happening? You will see that SPSS is now communicating with you, and it's communicating with you in a so-called output view or output document. And you can save that output document independent from the data set. So you can save all the analysis that you did for a certain data set in an output document. First thing that you can see here are different statistics. You can see the number of valid data sets or cases. In our examples, we can see that there are 97 valid values and 5 missings. So there were 97 countries for which the data was available and 5 countries for which we had missing values. You can see that we have a mean, a median, standard deviation, and variance value for the different variables. So we can see that the mean GDP per capita in current US dollars is at 19,714 US dollars. The median is at 10,985. We know the difference between a mean and a median value, of course. The mean simply is the average of our data set, and the median is the value that splits our data sets into halves, so the value that's in the middle of the data set. When do you use the mean? When do you use the median value? You should know that by now as well. The median value is of advantage as soon as you have a data set where you have very strong outliers at the end of the data set, because it simply is the middle value in the data set. The mean is very much affected by these outliers. So it depends a little bit on the perspective that you are interested in taking, whether you would like to use the mean or the median value.
Then you can see a frequency table. The frequency table for the GDP per capita and current US dollar does not help us very much, as you can see that it's just listing every value with a frequency of 1 here. So a frequency table rather makes sense as soon as you have categories of variables. And I will scroll down, it's a long table, to the second variable, which is our classification of countries. And you can see here that we have our classification of low income, middle income, and high income. And you can see that we only have 1 country that was classified as low income, 50 countries that are classified as middle income, and 46 countries that are classified as high income. That might be due to the values that I have chosen as thresholds. You can see here that SPSS is providing percentages and valid percentages. Valid percentages are only related to the datasets or the cases in the dataset that have no missings. So 97 values are given, which is 100%, and we can see 51.5% of our countries are classified as middle income, referring to the valid percentages. You can also see that it's providing cumulative percentage values, simply summing up the respective percentage values in each of the categories. What else can we see? We can see a histogram. And a histogram is nothing else than the graphical visualization of a frequency table. And I will immediately scroll down further to our classification variable. We can see here that we have countries, the highest number of countries falls into the middle category, only 1 country to the category of low income, and a couple of countries falls into the high income countries. So this is just a bar chart representing the frequencies. Another thing that we can see here is the normal distribution curve. So this can be helpful to identify whether the data that we have in our dataset is normally distributed. You might know that for several statistical procedures, it is a prerequisite that data that we are using are almost normally distributed. We will get to know several statistics for that, but immediately by looking at that chart, we have the feeling that our data is not really normally distributed in that case, because there's quite a huge difference between the normal curve and the representation of our data here. There are also other options to calculate descriptive statistics. I will jump back into the menu. As soon as you click on Analyze, Descriptive Statistics, you could also open up the menu which is called Descriptives. And in Descriptives, again, a new menu opens up where you can choose the variables that you are interested in. I will choose the same variables that I have chosen right now just to show you what the difference is between the two. I will choose what was a GDP per capita and income classification. We can click on Options, and there we can decide which statistics we're interested in. Mean, standard deviation, variance, minimum, maximum, range, whatsoever. And we can click on Continue and click on OK. There you can see that SPSS is providing only 1 table, so it's not providing a frequency table and it's not providing any kind of charts. It's just providing us an information about the minimum, the maximum value in the data set, and the mean. And that is the same mean value that we have seen in our other output already, $19,714 as a mean GDP per capita. We can also see the standard deviation and the variance of that variable. What often is the case in statistics that you are interested in comparing mean values between different sets of cases. So in our example, we might be interested in comparing the mean value or the mean GDP per capita for the low-income countries to the mean GDP per capita for the middle-income countries to the mean GDP per capita for the high-income countries. For that purpose, we would need separate calculations for the 3 different groups of countries. How can we do that? One option to do so, and I find that pretty easy and straightforward, is to split the output of any kind of analysis. For that purpose, you click on the menu and click Data. And there you can see that you have a lot of different options. And the one that is of interest to us is here at the very end, which is called Split File.
You will choose Split File and a new menu opens up. I will quickly increase it so that we can see. You can see that the default is Analyze all cases, do not create groups. You could also ask SPSS to compare different groups or just organize output by groups. The two options here do not differ very much. It's pretty much the same what you can see. It's just a matter of the format the information is presented. I will quickly say I would like to compare different groups, and I would like to compare the groups according to my classification of countries. So I would like to compare the results for our economies with low, medium, and high income. And I will specify that as a grouping variable. I will click on OK. That means for our further analysis that we are producing in SPSS, it will make a comparison of these three countries. So let us quickly click on Analyze, Descriptive Statistics, Descriptives, and ask SPSS to compare the GDP per capita. And I will pull that away because that is the grouping variable that we are using. So we are just interested in comparing the GDP per capita along these classifications. I will click on OK. And you will see that now SPSS is producing an output where it's comparing low income, middle income, and high income countries. And we have all the statistics given for the three different countries. We know that the low income countries have a mean GDP of 814. This is the one country. And we have the middle income countries with the average or mean GDP of $5,247 and the high income countries with the average or mean income of $35,849. So we now know what the different mean values are in different groups. And you can, of course, use this command for any kind of splitting the file. When you continue with your analysis after you have split the data file, please notice that SPSS will continue to split the file for any further analysis as long as you do not switch off that option. So before going on with any kind of different analysis where you're no longer interested in having separate outputs for different groups, you need to switch that command off. So you need to go back to Data, Split File, and say I want to now continue by analyzing all cases again. What you might be interested in is learning about the statistical significance of difference between mean values. So for example, you now can see that the mean value of the middle income countries is 5,247 versus the mean value of the high income countries is 35,849. So this is quite a huge difference between the two of $30,000. We might guess that this is a statistically significant difference because it's just a high value. There will be cases in your data analysis which are not so clear, where you need to check if the difference between these two mean values is not a random result, but really statistically significant. And of course, SPSS offers some options to do so. So let us take this difference between the two as an example to test whether there's a significant difference in the mean GDP per capita of middle income versus high income countries. For doing so, you will jump back to the SPSS menu and click on Analyze. And there you can see that there's the option which is called Compare Means. And Compare Means first offers you the option to just calculate mean values for different groups. We can quickly do so that you can see that menu. And you can say, I'm interested in calculating the mean value of the GDP per capita. You can click on Options to make sure what you have. You have the mean, the number of cases, the standard deviation. You could also go for a median here if you're interested in that. You can click on Continue. And then you can be interested in specifying the independent list, so the classification. And I will just put it in here and click on OK. And then you can see that SPSS is reporting the mean values of our three different countries. But now we're still interested in having the statistical significance between these differences. And how will we do that? Let us go back to the menu, Analyze, Compare Means. you can see that there are different options. One is called one sample t-test, independent sample t-test, and for example, paired samples t-test. These are the three most common options that we can use. What was the difference again between an independent sample and a paired sample? In our example, we would be interested in the mean values of different groups of countries: low income, middle income, high income. So what do we have? We have independent samples. So we'll jump into the menu of independent samples t-test. We then need to specify in the menu the test variables, and we are still interested in the GDP per capita. And we need to specify what kind of grouping variable is it that classifies different groups. It is still our income classification. There you can see it has like question marks here. So SPSS is asking us to further define groups. And in this menu option, it's a little bit inconvenient because you need to specify two groups which you want to compare. In our classification scheme, we have 3 different groups, but SPSS is only comparing 2 groups. So we would need to specify which of the 2 are we interested in comparing. And in my example, I would like to compare the middle income and the high income one. Middle income had a value of 2, high income had a value of 3. So I would like to compare group 2 versus group 3. Let us click on OK. And let's see what the output is providing us with. We can see here that it's again providing us with the mean values for the 2 groups. And it's then providing us with an independent samples t-test. Wonderful. And I'm pretty sure that you know what a t-test is. You remember from a t-test that the idea is that we compare the distribution of mean values to the t-distribution to specify whether our difference is a random result or not. We know by now that there's a high difference between the two of $30,000. So we would be pretty surprised to not see a statistically significant result. What is the hypothesis between the t-test for a significant difference of mean values? Do you remember that? Hopefully, yes. So the idea of that hypothesis test is that you specify a hypothesis for the difference between the 2 mean values. And you say you subtract one mean value from the other. And your hypothesis, your zero hypothesis, would say this difference is 0. So the mean values are completely equal. The idea of the hypothesis test is that you are interested in rejecting this zero hypothesis to have statistical support to say that there is a difference between the 2. So you have a zero hypothesis stating that the difference between the 2 mean values is 0, and you are interested in rejecting that hypothesis. When would you reject a hypothesis? As soon as you have a significant cutoff value stating that the difference between the 2 is higher than 0. You remember that there is an alpha level and a p-value. What was that? The alpha level is the probability of making a mistake in your assumption. Usually as a researcher, you would be interested to have a low alpha, so a high probability of statistically doing the right thing. What are accepted levels? Usually what you find in journal articles, you have accepted levels of around 10%, 5%, better 1% or lower. That means that your decision is with a probability of 10%, 5%, or 1% wrong. So the lower the better. SPSS is making your life very easy because it's reporting p-values, and it's always reporting p-values in a column where you see something like sig dot. So you see here sig dot and you see here sig dot. So this means that you have p-values reported over here. And what you can do in SPSS, you can simply compare the p-value to a specified or desired alpha. For example, let us assume that our alpha is in general 5%. That means in any kind of situation where SPSS is providing us with a value below 5%, we have a significant result and we can reject our hypothesis.
If you first only concentrate to make it simple on the right-hand side of this table, you can see that we have here in a situation where SPSS telling for a t-test, a t-value of -10 whatsoever, you can see that we have a 0.000, so a value which is clearly below 5%, meaning that our two mean values show a statistically significant difference. What is given here on the left-hand side makes it a little bit more complex, but in real life it does not change a lot. It is a test that is first done before starting with the t-test. That is a test for the equality of variances in the two samples. Because for calculating a t-value, if you would do it manually, and I'm pretty sure that you did it in your bachelor program, you would need to know what the variance is of these two samples for that certain parameter. So it's first testing whether there is an equal variance in the two samples or not, to then know which kind of row will I refer to. So what does Levine's test test? It tests for the equality of variances. So the assumption is that there are equal variances assumed, and we need to ask, can we reject equal variances or can we not reject equal variances? In our situation, we can see that here we have a significant value. That means we can reject equal variances. That means we need to have a look into the second row because we cannot assume equal variances. And we need to refer to this result in our table to specify whether we have statistically significant difference between our mean values. As you can see here, we have the same 0.000 for our values, and we can still assume that we have statistically significant different mean values for the GDP per capita in the two groups. I hope that the explanations helped here. To get that clear, I will try to also highlight it in a lecture a little bit more to make sure that we are on board with the significance testing. Unbelievable but true, I think we have everything we need to start with the first exercise of our dataset. Before doing so, I will save my data file under a new name. And you can save different files. You can now save your output file. You can ask SPSS to save the output because you've created a lot of statistics and you might be interested in keeping them. You might save your output file and you can see that this is saved as a viewer file and say first analysis 2018 whatsoever, and you can select a folder where you want to do so. Now you just select the folder and then you click on save. I'm not so much interested in keeping my analysis here. I will just cancel that. And I will jump back to my data file because I definitely would like to save the current state of my data file. So you could either save this right now, then the document would just be saved under the same name. I will not save it under the same name because I will give you the chance to create your own one. And not overwrite it. So I will save the file under a different name and I will call it International Markets stuff, and I will save it under my desktop. And then you can see that SPSS has saved a copy of that file. Please don't forget to save your file because you will maybe need some of the classifications, some of the recoding, some of the calculations later on throughout the course.